This is an AuthentiKit P40B throttle quadrant. In fact, it's very similar to the Harvard or Texan throttle quadrant, and in fact quite a few GA quadrants as well. This is the Spitfire throttle quadrant, and this beast is the Mosquito engine control box, or a throttle quadrant really. One thing they all have in common is that all the axes use the same control device to provide the axis input, whether that's for the prop levers, the throttle, or in this case the mixtures over here. It is a proprietary AuthentiKit device, and it's called a MagHall, which is a concatenation of magnet and Hall sensor. This is the one used in the mixture and the prop levers of these throttles. The white wire provides the signal input of the axis, and the red and the blue wires provide the power. It uses a high resolution Hall sensor which gives 12 bits of positional data, meaning as you move the axis it outputs a value between 0 and just over 4,000. In other words, it's pretty precise. MagHalls come in different sizes. This one has the device code MagHall 6803F, which means it's based around this 6803 bearing. And it includes a cork disc inside which provides friction, that's the F. Other MagHalls are available, such as the 6003, the MagHall 6003 used in the flight stick. It's much tougher and it's based on this 6003 bearing. Now these things are used in washing machines, so they are tough. There is also this variant of the 6803F called the 6803HXF, which means the H is for hydraulic damping, the X means the hydraulic damping is external. Here's the hydraulic damper, it's kind of external to the unit, and it meshes there. You attach that to the lever, and it's got an F as well because it has a friction disc in as well. So this is the type we often use in a throttle lever, just to give you that extra bit of resistance with the hydraulic damping. In fact, it could go into any lever if you design it that way. Now later this year, I will be releasing the CAD for you to design these into your own controls, along with a collection of design guidelines built up over several years of me designing things and improving these controls. So that's coming later in the year, and subscribe if you want to see that. In this video though, I'm just going to spend a little more time than I normally do showing you how to assemble these. So this is the hardware that you need. You need the right size bearing, so that is the 6803. You need the magnet, you need some wires. I've just got some short pieces here for this demo, but the wire length is going to be dependent on the control you're making. You need the cork disc, that's sticky back, and you need the Hall sensor, these ferrules, tiny little crimps, and 3 screws. That screw length is right for the 6803. There's a link in the description where you can find more specific information for sourcing these parts yourself, but if you just want to buy a kit with everything in, then if you're building a specific flight control, the kit will have that in. If you just want to have enough parts to make controls yourself, then our friends at SimKit Supplies can sell you a kit. Construction Kit 1 has everything to make flight controls, and it includes enough for 5 of these MagHall 6803s. You can also get the axis pack from them, which is just kind of a top-up, and that will give you 5 axes, 5 MagHall 6803s. And these are the printed parts you need, just 3 parts. And I'm showing them the way they are printed, so it's, you know, that's kind of upside down actually. It ends up like that. That's the right way up for this one, and that's the right way up for this. So you'll need your printer set up right. These tiny little parts need to be printed onto the print bed. There are some other considerations about printing. I will come to them as we go through the assembly. So let's start with the base. The sensor goes in the slot from the top, like that, drops in. Now one important thing, it must not sit proud. I mean, a tiny bit proud would be okay. If you printed it right, it will be perfectly flush. Actually, that's one of the reasons to print it that way rather than that way. If you printed it that way up, you would find that this does sit slightly proud. You'd get a little bit of a sag in the base of the place where the Hall sensor goes, and that would just push things up. Now let's turn this over, and we need to bend these legs down into the channels. Not all the way, not at this point anyway, because we've got to put the wires on later. But for now, just enough to hold them in place, and so it doesn't sort of drop out and it just seats properly. So you need to just tease the side legs apart a little bit so that they're in line with the channels, and then with the screwdriver just push things down. So you want it kind of like that. There you go. So it's not quite 45 degrees, it's almost sat in, and they're ready to go in place in a few minutes. That's good enough for now. Next, cork disc. Peel off the backing, pop it over the top, make sure it is central. That's important, or it can start to smear to the sides under load. And that's why the little grooves at the side are here, just to help you align and get that cork disc bang in the middle. That's it, that's the base done. So you can't go too far wrong with that one. However, some people do struggle with this one. We're going to fit this magnet into that square cavity, and we have to do it just right. This is also where you'll find out if your calibration is wrong, as the magnet should press fit into here and it should stay in there. You don't want it loose, otherwise the magnet could move around in there and that give you incorrect readings. And you also don't want that hole too tight or effectively too small, because you just won't get the magnet in. It should push in with a little effort. If you really have to jam it in, you're going to have the problem that you might find later that it's not in correctly, and then you've got to get it out again. If you do have to get it out again, you can push a screwdriver through that hole and shove it through. However, if you follow my instructions, you will not get it wrong. So firstly, we need to orientate this magnet so that the North Pole points towards this dimple. Now if you can't see that dimple, again it's because your printer isn't set up right. You've probably got the bed level too tight, and that dimple's kind of got squashed to the point that it's not even visible. So just to emphasize that we want the North Pole pointing acrossways towards that dimple. We don't want the north pointing down into the cavity or sticking up, but going across. So how do we do that? How do we know which is the north on that cube magnet? Everything looks the same. So that's where you need another magnet, a red-blue magnet. Now these don't come in the construction kit or the bill of materials for any particular control. That'd be kind of a waste because you only need one for all the things you ever make. So they come in the starter kits, such as the Universal Hub Starter Kit. So we hold the red-blue magnet so that the blue side is facing out. That's the south. And then if we just drop the cube magnet onto it, now we know that the face of the cube facing the blue is the north. Now at this point I recommend a small flathead screwdriver. Don't use a spoon or something like that. Use something with a little bit of control. Point the tip towards the marble. Hold the cube magnet just so it doesn't flick too readily, and then attach the screwdriver so it's holding the magnet. Now we know that the tip of the screwdriver is pointing to the north. Carefully pull away the red-blue magnet. We don't need that now, it's done its job. So again, we're pointing north, there's the dimple, and we press flat the cube into the cavity, and in it goes. It won't drop out. It's quite firmly in, but it's not so tight that I couldn't push it out if I find I've got it wrong. But there you go, you can see it lifting out. But I don't need to do that because I've got it right. Another thing to watch with your printing, the magnet, again, like the hole sensor, should not be proud. The teeniest bit proud maybe, but you can see there it's not proud. If it was, because it's making direct contact with the cork and it's just rotating, then over a period of time it would just crumble the cork, break it up and just damage it. Now the bearing. The bearing should be a tight fit over here. The later versions of these MagHall pegs, I call this the peg, I've got tiny little, if you can see there, little tighteners, I call them. They'll deform as you press the bearing over it, so initially the bearing sits on without too much trouble, and then as you press it on, it gets tight. It's important that it's tight. Now the cap. Again, the cap's got little tighteners on it, so that as that goes on, press that hard, and that is a good tight fit. So there's no slack, no movement. We'll get reliable results that way, and that moves freely within the bearing. Now we screw the two halves together. These pieces won't touch. Don't worry if you see a gap in there, that's normal. That's because we're compressing the cork slightly, so we need a little bit of allowance to allow for that compression. The screws for this are 14mm, and when they are in and screwed down, they should also be flush with the top here. Again, it's printed that way up, so there is a possibility that those holes could narrow a bit if your printer isn't quite right, but you want the screws screwed all the way down so that they're as good as flush, very, very close to flush. If not, then as levers rotate over the top of the here, they could catch against the screw head. So there's another thing to watch for with your printing. It's also important that the screws are not loose in here. Any slack of the screw inside the screw hole could mean that the cap would have a little bit of freedom of movement forced on it by the lever, and you would get incorrect results. So the holes are designed into this MagHall to be deliberately tight, but that creates the possibility that you might get some binding as well. And the thing you need to therefore do is put the screw in and drive it through and keep on turning until you don't have a problem with binding. And you can see here now that that screw head is flush, almost recessed under the cap. So we do that for all three screws. And there we go, no binding. And now we can put the two halves together. Just do a little bit on each corner, bring the pieces together incrementally. And remember, it's really quite a small sliver of a gap when you're there. Okay, now I'm starting to get some bite on that. Now we won't go into detail in this video about how tight that should be. That is generally something I cover in a flight control assembly video. And as I said before, the screw heads are not sticking proud, and the gap here is a very fine, barely a millimeter. Okay, let's finish this off and do the wiring. Now, remember this sequence. RBW, red, blue, white. I would recommend drilling it into your head because it's one of the areas of potential mistakes that you can remove just by memorizing that. I always just say RBW, RBW. For some reason I think Robbie Williams. That's my little thing. Come up with your own so that you always get it right. And let's start wiring up. This is how you do it. You take the silicon and you, with your fingernail, rip off a tiny 4mm, I would say, 4 or 5. Pick up one of these ferrules or crimps and slide it on like that. Oh, I gave it a good twist, didn't I? Make sure you give that a good twist because you don't want any frayed ends. And it'll also go onto the ferrule a lot easier as well if you do that. Then RBW, red on the left. Slide it on and slide past as well so that a little bit of the leg is protruding. And you want the crimp to be about 1 centimeter up, because as it gets narrower it gets a little bit tighter and you want a good grip of that crimp. That seems like a good point. Yeah, you see I can press that in with my finger. I could probably go a little bit further along again, but it doesn't matter. That's a good point for it because now we crush it down. I'd use a screwdriver like that again, quite a narrow tip on it. Hold it kind of like it's a diagonal across the channel so that when you crush it down, you definitely crush it and the wire, yeah, is gripped. That will hold on. And then the wire with the insulation around it just tucks in the end. So that's one. I'll show you again. So with your fingernail, there we go, same sort of length, good old twist. One of these ferrules. I've gone W. RBW, right. Keep saying it. Blue next. One of these ferrules. Push it on, slide it past a bit. I think this middle channel is slightly wider than the others. I'm going to push it a little bit further. Yep, it goes in with my fingernail. Crush it with the tip, make sure it's tight, it should be able to hold on by itself. That's the second one done. Make sure there's definitely no little bit of a fray crossing the channels. You definitely need insulation there. Last one, RBW, crush it in. Is it holding? Yep, it's holding. That's it. RBW, done, all wired up. That is a MagHall 6803F. It's ready to use in a throttle unit or a collective or even a Spitfire gun sight. Now the 6803HXF is exactly the same in terms of the assembly. It just has this sort of spiky hair thing at the top. In fact, all MagHalls are the same in terms of assembly, although some of them lack the cork friction disc. Now in time, I'll be taking you through the assembly of the full range of AuthentiKit control devices. We've got the McClicks, the Rottens, there's buttons and a few more, so make sure to subscribe if you want more of this. And I'll be back just as soon as I can with more flight controls and more assembly videos. Bye for now.